Just a couple of quick notes first. My name is Finn Sagnen. I'll be your host today.
Excellent. So good afternoon, everybody. My name is Joachim Lindholm. I'm the Managing Director for Altair in the Nordics region. So Altair is a US-based simulation software company that also does services, artificial intelligence, high-performance computing, and all sorts of things. But today, as all the naming confusion implies, we'll be talking about simulations. So we have quite a few different products and platforms called Sim something. So we spoke last time we presented on the Alfasoft demo days, we spoke about the product called SimSolid, which is a solution that allows you to analyze really large assemblies directly on the geometry level, basically, and get results like stress and deflections and deformations and eigenfrequencies and so forth. But today we'll be talking about a solution called Altair SimLab, which my colleague Himanshu will be doing a deeper dive presentation and demo of in a couple of minutes time. But before that, I wanted to give you a very brief sort of insight into who Altair is and really where we come from and why SimLab is something that we hope you will find interesting. So just to give some background to who Altair is, we basically come from a background. Let's see if I can change slide here. Seems like it's, there we go. So Altair is a company, as I said, in the engineering software industry. So we started out as a company doing engineering services in the simulation space, doing sort of strength and stress simulation in the automotive industry, but quite early on started to develop our own simulation software to be able to perform those analyses. And currently we still have that as some of the main businesses of us. So we develop simulation software, we perform services within simulation, but we also work in other domains. So one area that's also a sort of technology for predicting outcomes of different systems or products is doing it on data using methodologies like artificial intelligence or machine learning and so forth. So basically analyzing and predicting things based on data rather than on physics, which is what we're doing when we're talking simulations. So those are two areas we're working with, and both of them can be quite computationally heavy and require a bit of computational resources. So we also work quite a bit with high performance computing, so large compute systems and all the infrastructure that are required to make them run successfully and efficiently, both sort of on premise, but also in the cloud. And we do this both in terms of the services or the software solutions, but we also offer services in all these three categories. And just to give you a bit of an understanding about who we are working with, so basically all the large technology companies of the world across various industry segments use our software in one way or the other to develop their products. So especially in areas like automotive and aerospace, which are very sort of simulation driven and optimization driven in their product development, you see quite a large use of our technology. But also other sort of different type of segments across all potential sort of industries and all sorts of physics is where our softwares are used. And just to look in a bit more in, so today we'll be talking purely about simulation. And in terms of simulation, we're capable of simulating all sorts of different physics. Things like structural mechanics, where we look at stresses, deflections, vibrations and so forth on mechanical structures. We can do that both in terms of static analysis, also sort of highly nonlinear transient behaviors like vehicle crash, drop test of electronic equipment, explosions, blast and so forth. We do a lot of computational fluid dynamics, where we study the behavior of fluids and sort of thermal simulations. We do work in electromagnetics, which is both sort of on the low frequency side for, say, electrical motors or power transformers, things like that, but also high frequency. So for communication purposes, designs of antennas, looking at wireless coverage and so forth. We have a quite extensive set of manufacturing simulation, which allows you to study what happens in the manufacturing process for processes like casting, injection molding, sheet metal forming, extrusion, and 3D printing and so forth. And we're also doing quite a bit of system simulation. We can have both sort of block-based type simulation, where you can also couple in fully fidelity 3D finite element models or multi-body dynamics models or something as part of the system simulation. So as you see, the solution set is really extensive, and what we've done to kind of tailor these solutions to different sort of user groups, we package them in a couple of different simulation platforms. So for the large group of designers who benefit from being able to do some basic analysis to sort of support the concept phase and get some insights and understanding that they can use in terms of enhancing the design, we have a simulation suite called Altair Inspire, which is really easy to use, fully geometry based and really intuitive. On the other extreme, where we have the really sort of skilled and highly competent advanced CAE engineers who does simulation every day and 8 hours a day more or less, typically find those people in automotive aerospace companies where they have large groups who are doing this every minute of the day. Really, there's this platform called HyperWorks, which allows you to do very complex and advanced modeling. And then in the middle here is what we will be talking about today, and that Himanshu will be starting to showcase shortly, is a platform called Altair SimLab, which really allows you to model and simulate problems from a lot of different physics, both as single physics. So you can do a structural simulation on itself, or you can do CFD simulation on itself, but you can also start to couple the effects of these physics. You might have a CFD solution that imposes a pressure that results on mechanical stresses on the system or things like that. So today we'll be going a bit deeper into the Altair SimLab platform, and as I said, my colleague Himanshu will be doing that. So if you could please turn over the control to Himanshu, he will take it from here.
And I hope you can see the full presentation view here, right?
Yes, we can.
Absolutely, thank you. So let's get started on the SimLab. Joachim already introduced about Altair, so I'll directly dive into SimLab. I am a technical guy, so mostly I'll be talking about the technical stuff related to SimLab. But before that, for a few minutes, let me introduce about the solution capabilities of SimLab and also the modeling capabilities. So whenever I present SimLab to users or during conferences, they ask me to define simulation software in minimum number of words as possible. So I usually define SimLab as an automated multiphysics simulation environment. So 4 different words that we use. It's highly automated. It's multiphysics simulation environment. So yes, you can do single physics as well. But if you want your physics to interact with each other, we have a tool called SimLab here at your disposal. So if you're someone who deals with 3-4 different physics, let me just move the slide a bit. Okay. So you can see Altair SimLab in the middle, and it can deal with static dynamic stresses, fluid flow, electromagnetics, injection molding, which is a manufacturing simulation. We got you covered with Altair SimLab. And if you're someone who deals with 3-4 different physics day to day in your life, be it structural, fluid, electromagnetics, and if you are too lazy, or I will say too smart to learn different tools for each of them, we got you covered here at Altair, and Altair SimLab is here at your disposal. So again, to summarize about Altair SimLab, it's one environment to solve all of your physics needs. Moving forward, so apart from the usual process, which usually all preprocessor packaged with the solver can do, that you can bring in a CAD mesh and set up the model and analyze it, what you get in SimLab, it's automation capabilities, and it's go way beyond just analyzing the model. So you can actually set up additional design of experiment runs, or you can do mesh convergence study or couple physics analysis, as I'm repeating way too many number of times, in a single environment, which is SimLab itself. So it just does not stop you on just the post-processing part. You can take and do like design convergence or design of experiment studies to analyze what factor of design is affecting, let's say, stress in your model. So yet it's go beyond just analyzing the model. What sets SimLab apart from its competitor in the market? So let's talk about few notable features we have. It's SimLab's ability to cater the needs of everyone in the industry. I will say it's not just someone who is really advanced into FE environment, or it's not just who has just started his FE career in the environment. SimLab is a perfect balance for all type of industry professionals. So let's say if you are a design engineer and you don't want to spend a lot of time meshing the component, SimLab's single click meshing is ideal for you so that you can just mesh the component, don't spend a lot of time in understanding those meshing process, just give it a quick run and see how the model is behaving. Or if you are a simulation engineer, as Joachim said, if your job is to do simulation 8 hours a day and you are very particular about the meshing quality that you get, SimLab provides excellent mesh control strategies to generate very high quality mesh, and then you can delve all of your time meshing each and every single component with utmost precision and hence analyzes to utmost accuracy as well. Or if you are someone who are already very advanced into his career or leading a team, or if you are a manager who is looking to set up some robust repeatable template based simulation for your team so that you can set up some workflow and later on your team can follow those, right, in order to reduce accuracy and it can be repeatable. SimLab will let you do without actually scripting. So we do have like templates based solution available inside it. And last but not the least, if you want to automate each and every single step of simulation inside SimLab, you can use very simple Python script, which I'm going to showcase in the live demo as well, to create or to automate, I'll say, each and every single step of automation, right from CAD import to post-processing. Yeah. So these were the few notable features which really set SimLab apart from its competitor in the market. Some of the typical industry applications of SimLab. So as we were mentioning, SimLab's 3D meshing and automation capabilities are being widely used in powertrain industry with engines and gearbox and brakes and whatnot simulations. Or you can also model detailed welding inside SimLab, and later on you can take them to fatigue simulation. So something which is really important for powertrain industry, or I'll say automotive industry here. Another thing is SimLab's multiphysics capabilities, especially electromagnetics, thermal fluid, and noise simulations, like make it a very widely used tool in electric vehicle domain. And last but not the least, its ability to easily create hex meshing tools like hexahedron mesh makes it one of the favorite tools when it comes to consumer electronics study here. So you can like easily do hex meshing and then subsequently take it to drop test or explicit simulations. Mainly the industry that they are using SimLab's explicit simulations are consumer-based industry like small electronics industry. So this was a brief about SimLab. I do have here like slides close to hundreds that I can keep talking about. But right now I would like to jump directly to the demo part. And maybe if we have time, I can come back later to the PPT and talk about more physics. So let me just go back to the SimLab environment. Okay, I'll just open an empty SimLab session with you. The tool currently in release right now for SimLab is 2022. If you are already an Altair user, you know about Altair One account, that you can create an Altair One account and you can go to Altair Marketplace here on the Altair's website, and then you can download SimLab from here, just like the way you download other Altair tools. If you are someone new to Altair, you can get in touch with Altair's marketing team on the website itself, and they will guide you how you can download the demo versions and all the softwares that you need. So this was about how you can download SimLab. Once you have SimLab into your system, you can also run it on the Altair cloud based on your licensing type. Right now, I'm going to using on my local machine. So this is how typically SimLab's environment looks like. So you can see straight away on the GUI the different physics that we offer under solution tab. So it can start from structural, thermal fluid, electromagnetics. We have done a lot of work this time in this release about e-motor acoustics. We do have a manufacturing simulation, injection molding. You can model weld with, I will say, utmost precisions, and then you can take it to whatever solver you want. One of the notable features that I forgot to mention about SimLab, it's solver neutral. So you can actually do all the processing in SimLab, and then you can take it to any solver of like you want. So we never restrict our user to use any particular solver, but obviously we would be more happy if you're going to use Altair tool, which are OptiStruct, Radius and all. But you are free to model completely in SimLab and then take it to anything you want, be it Abacus, ANSYS or Dynam, whatever caters your need perfectly. Yeah. So yes, it's a solver neutral platform, which also sets it apart from its competitor in the market. So let's look into, since we are talking about multiphysics today, let's look into a live demo of multiphysics. So what I'm going to be showing you is a thermal fluid interaction solution, and then I'll taking that, or I will combining that with the structural run. So let me bring in the CAD first. So in the import option, you have different import option. You can either import SimLab database, or you can have multiple CAD files. You can be importing different solver inputs coming from different solver. It might be Altairs or it might not be Altairs. You can also see post-processing results that you can import, or specification files, let's say mesh or materials or whatnot. Right now, I'm just gonna import a SimLab database. So I'm not importing a CAD. So if I open it, this is a simple exhaust manifold geometry. So if I come to the assembly browser, you can see the geometry being reflected here. The visualization option can be figured out using either right click, or you can just click next to the model, right? As I was mentioning, let's give it like a single click meshing. So I will go to mesh, surface mesh. If you are not even willing to spend like 5 or 10 minutes even on meshing, you can just directly jump onto the TET meshing side and just do like a small, I will just change the units to millimeters. So you can also see you have, it's a unit based system, so many units are being supported here. So mmks. Okay, so you can directly like create 3D mesh out of it without giving much attention on the detailed surface meshing. Right now I will just be doing a surface mesh and just putting a demo size of 4 millimeters. You can play around with all the other factors as well. So just hit OK here. Yeah. So average element size I'm putting, you can also control it through, my bad, sorry. You can also control it through maximum element size as well, just or grade factor or whatnot. So yeah, so it hardly took like 30 seconds for creating mesh of this bit complex looking part. And if I zoom in, the details looks pretty good to me, at least from visual point of view. You always have an option to go and check the qualities as per your requirement. And since now I want to create a fluid solution, and I also want to create like a structural solution out of it, by rule of thumb, I will try to keep few layers of element inside this solid. So you can see there's just one layer of element. So you do have like bunch of options which will let you control your mesh properly. So right now I'm gonna go into the layered mesh option, just select this change layer option. And here I can control the number of elements that I need to be creating on axis or along the radial direction. So right now, let's say I'll click on this face, and I want 3 layer of elements on the surface. So I'll just hit OK here. So you can see with the use of single click without using much complicated tool, now you have splitted those single elements into layer of 3 elements. So this was happening just on the surface, but you also do want to create 3 layers of element inside the metal pipe. So I was mentioning you have detailed mesh controls. So when you want to take it from a surface mesh to a solid mesh, what you want in middle is 3 layers of element through the thickness of the pipe. So I will go into the mesh controls now. And I'm just, so these are the options which will let you control your mesh more effectively and will have like greater control over mesh. So I'm just gonna say volume layer mesh control here. And on this particular body, so I'm just selecting the body. I'm telling the software that I need 3 layers of TET. When I convert that into tetra element mesh, I'm just gonna hit OK. And if I go to the mesh control panel now, you can see that SimLab is telling you that on this particular body, you have applied a mesh control with the name volume layer mesh control, right? Okay. So one control that I wanted SimLab to apply on my meshing model. So this looks like a good mesh for at least the pipe. Now, since this is a thermal fluid interaction multiphysics simulation, we also do need to create like a fluid domain inside it. Okay. People who are familiar with CFD run will understand the importance of how complex it gets when you are asked to create like a fluid domain inside a solid. So SimLab makes our life easier in this case. What I'm going to do is I'm just going to separate out the faces where the fluids is going to touch. So in other tools, or you might be selecting these one by one, or you might be having option select adjacent, but this is not enough when it comes to very complex geometry. So SimLab does provide like intelligent selection tools. We'll teach about those tools in our detailed training. Right now, I'm just gonna select a face, right click and say select adjacent layers. And I will tell SimLab that you can stop your search on these faces, and whatever faces is coming in between these two faces under angle of 80 degree, select that for me. I'm just gonna hit apply. So you can see SimLab have selected all the internal faces of this solid, and I'm just gonna close this tool, right click on my screen and say isolate. You can also use shortcut menus. So I have isolated all the internal faces of this pipe right now, and I am just going to create now a fluid domain on top of it. So I am going to go on the geometry, say create, and we directly have an option of creating fluid domain. So I'm going to select fluid domain, wetted surface where the fluids is going to touch. I'm going to select all of these, and you do have an option of selecting or meshing the inlet and the outlet face with a different size. Let's not go into it right now. I'll just rename that as fluid and just hit apply. So this might take like 30-40 seconds, not even that. I think it hardly took 5 seconds. So now I have created fluid domain. So I have two surface meshes with me right now. One is for the pipe, one is for the fluid. Okay. I can always hide them and show them. So you can see inside the pipe, you have now created your fluid domain. Okay. Again, it's a CFD based solution. It's a fluid and structure interface. So what we do want to do right now is to create boundary layers on the fluid. Again, people who are familiar with CFD, they know how difficult it is sometimes to create accurate boundary layers, which is like have utmost importance when it comes to CFD flow simulations. So let me now go to the mesh and select CFD. So as I was mentioning, we do have different meshing tools available. It's a multi-physics environment, so you not only have meshing tools for solids, you can also create hex if you want to do some explicit simulation, or you can create CFD mesh. So right now I'm just going to create a CFD mesh, right? It's asking you, it's very interactive. It's just asking you to select the fluid bodies that you want to create CFD mesh. So I'm just going to select my fluid. Where do you want to create, do you want to actually ignore boundary layer creation on the faces? So I'll say I want to create boundary layer on inlets and outlets. If you wish, you can do that. You can just leave this empty. I will keep the first layer thickness as 0.5. Hope it's in millimeters. Yes, it is. And I'll just keep total number of layers as 5 and average element size. I won't play around with that. If you want, you can use more control over it, and I'm just going to hit apply. So this might take few seconds, but meanwhile we can discuss this option. So you do have few options where you can change the thickness of the boundary layer. So instead of keeping each boundary layer as constant thickness, you can tell the software that if you want it gradually increasing or gradually decreasing, those can also be changed. So if I zoom in into my mesh now, with a single click of you, with bunch of clicks, you can see it has beautifully created boundary layers on the fluid domain. And also now the mesh has been converted from a surface domain to a solid domain, you can see. Let me just hide this fluid. So our fluid domain is ready with us. I'll just hide this and open the solid pipe. So the pipe, the solid pipe still is surface mesh. We want to create it into 3D mesh. Single click option in SimLab, we'll just go to TET mesh. We will just select the order of the element we want, maybe first order, second order, based on your need. Then you can give the element size, and here you can control the quality criteria that you want SimLab to follow. Let's say usually I say my TET collapse to be 0.12. I keep it for OptiStart. You can have your different requirements. You can control it from here. Okay. Right now I want SimLab to keep a minimum value of 0.12 for TET collapse. So I'm just selecting that part and hitting apply and say okay. So this is now going to create like TET4 elements inside this surface geometry, right? In an ideal world where you want to pay more attention on your meshing, the process would be to create surface mesh, clean it up, check if the qualities are good enough for your requirement, and then take it to the TET meshing tool. All the meshing parameters can be seen here in the output window. At any point, if you feel you want to abort the meshing, you can just simply click on the red icon here and the meshing would be closed. So it's almost done. The meshing looks like it's been done in 13 seconds for this complex model. Yeah. Similarly, you can use advanced option under the TET mesh settings, since let's say if you have created a very good surface mesh and you don't want your preprocessor to play around with the surface mesh, you want to keep the surface mesh constant, you can just go under the advanced tool and tell SimLab that you are not allowed to play around with surface mesh. Just use whatever I have given you and create TET mesh out of it. So that's how you can control TET mesh out of it. TET10 straight edges and TET10 curved edges. TET10 curved edges would let you control two quality parameters in SimLab, and TET10 straight edge will just let you control one quality parameter here. So all of these, whatever I'm doing, is being recorded in a simple Python script in the background that we are just going to open in our second part of the demo. And the automation part starts from that point itself. So you can just simply copy those commands. Whatever mouse clicks I am doing on the GUI can be copied from a simple Python script. You can copy that to your own script, and then you can just simply run that script to create automation. That's the part of the second demo. Maybe for this webinar, I feel I have clicked like at a wrong place. That's why it's taking so time. SimLab is telling you a number of iteration it took for it to clean up the mesh, and it's done. So I'll just cancel this tool. Now you can say pipe and fluids both are now being converted into 3D meshes. Okay, so a nice looking layered mesh on the solid as well in order to achieve that accuracy. Then like a constant volume layer thickness and fluid domain in the middle. If I take a section cut of this model and just show you how it looks from the inside. So if you remember, we had given a volume layer mesh control to SimLab. We had asked SimLab to create like 3 layers of element inside a solid to achieve desired accuracy. So you can see there are 3 layers in the pipe itself. So these are solid layers. These are not boundary layers. And this is like your fluid layers, which are called boundary layers in CFD terms. And then there is a fluid domain. So it looks pretty decent mesh to me, at least for single click point of view. So there you go. So your mesh is ready with you right now. Next thing is to take it to the solution and set it up. Okay. So meshing itself is ready. Now let's go to the solution tab, okay, and create a solution. And right now I am going to create an AccuSolve fluid solution, like steady state fluid flow. The bodies that are going to be undergoing solutions are all of these, like 2 bodies, fluid and pipe, incompressible fluid, and some turbulent model. And I'm just gonna hit apply. Let me just rename it as flow simulation. And I'm also including heat transfer into it. So just hit OK here. So first solution has been created as fluid. Before jumping into boundary conditions, let's create material. So SimLab offer a few default materials inside it already. If you're not satisfied with those materials, we have a library from where you can actually import material. So you can go material, not on the creation, maybe I'll go onto the database. And we have materials supported for different industries, electronics, polymers, fluids, and all. Right? You can either import it from there, you can or create your own material database, whatever you want, if you want to populate it across your team. Right now, what I'll do is I will just import a stainless steel material that I just created for the sake of this webinar. So I'm going to import a material. Right? It's extremely easy to export the material also. I've just exported it already, so I'm just going to import it. So the material is now into my SimLab database. I can use it. Now I will go onto the bodies in my, you can also select the bodies and assign material to them. I usually do it from here. So material to pipe, I'm going to assign stainless steel. To fluids, I'm going to give air. Come back to solution, set up the boundary conditions. So it's pretty intuitive to set up the boundary condition. The workflow of SimLab also moves from left to right. So for inlet boundary condition, let's just change the unit to MKS, right? And I want the inlets to go from these phases at a velocity of 8 meters per second and at a temperature of 700 Kelvin. So I'm just gonna hit apply here. Outlet, I want to keep at 0 pressure. I just gonna tell SimLab that this is the outlet. You can just change the name whatever you want and just hit the apply. So inlet outlet is done. Now let's just give wall boundary condition for fluid flow. So first I'm going to select all the faces where I want to give wall boundary conditions. So instead of like doing single clicks on all of the faces, I am just going to select one faces from all the domains that I want. So one face on top here, one on the bottom, and one on the side, and then use automated selection tool that SimLab offers. Say select adjacent layers and just hit apply. So now SimLab have selected all the outer faces. I'm going to isolate them. These faces are now isolated, you can see. And I can easily apply a wall boundary condition by just drawing a rectangle around it. So just drawing a rectangle. I want to give a convection boundary condition with the heat transfer coefficient as 20 watt per meter square Kelvin and the reference temperature to be 30 degrees Celsius. And I'm just gonna hit apply. Now I'm gonna redisplay the model. So we are all set as far as fluid solution is concerned. You can right click it and update it. So you can see right from CAD import to solution, we never exported any solver deck or anything. Everything has been taken care in SimLab interface itself. It's a complex model. The meshing is fine. So the solution will take some time. So I've already solved this model for, if I open this, so this solver solution is already solved here. Maybe what I'll do is I'll just open the flow simulation solve. That was like a complete solution, flow and structure combined. So let's see if I have just the flow solution with me. Yes, I guess I have. There you go. So this is just the flow solution. So the boundary condition that we gave in the webinars are exactly same here, inlet, outlet, and just wall conditions. And the temperature, you can see how it's varying. Yeah. So this was just the one physics. Now let's set up another physics, which is structural run. So I am going to right click on the GUI and hide the results. Okay. And from solution, I'll say right click, create solution. And this time I want to create OptiStruct linear static solutions. Okay. And the bodies that are going to go under the simulation is just going to be the solid steel body or stainless steel body, which is pipe. So I'm just going to select pipe and hit OK. When I come back to my solution tab, you can see that now we have two physics. One is flow and maybe I can rename that as static. There you go. Now let's apply boundary conditions. So mesh, I will just isolate this mesh so that you have only those bodies which are undergoing this simulation. So just go on to the constraint, fix this guy, and also fix the bolt location. So just come here, and just quickly fix all of them. Right. There you go. So this is just about static run. Now comes the multiphysics capability of SimLab. So copying loads from your previous solution is extremely easy into SimLab. Since you have two physics inside it, SimLab automatically knows that at some point of time you're going to link those two. So if you right click on your load and constraint, it's already giving you option. Do you want to include temperature from your previous solution, which is flow? Or do you want to include pressure from your previous solution? Or maybe you want to include both. So let's include the temperature first. So temperature is mapped onto these elements now from the previous solution. Similarly, what we can do is we can just select all of these faces and tell SimLab that I also want to map pressures from my previous solution on this solution. So just map pressure on it. Mapping pressure takes some time, like 30-40 seconds. I might need to wait for it. Since it's mapping each and every single pressure that was solved in the previous run on this run now. So both temperature and pressure now are mapped onto this solution. You can simply right click on the results and say update. It's gonna solve both the physics combined. So first physics is already solved. So whatever matrix are coming from that physics is now being copied into the second physics and it's gonna solve it. I have already solved it. So you can see this is the flow solution and this is a static solution, right? If I just play a scaled version of the animation, this is how the hot air flowing inside this exhaust manifold and the pressure that it's applying, this is how it's deforming it in when it comes to like the static part of the thermal structural interaction part comes. So this is a scaled version. The deformation that we are seeing is 2.6 millimeters. We do have detailed post-processing tools that you can play around with later. But let's finish this multi-physics simulation or demo right now and move on to the automation part, which is again interesting part of SimLab. So this was about multi-physics. We do have like way too many physics that you can combine all together. Let me just quickly go on to those physics and show you a glimpse in the PPT. There you go. So the physics typically that SimLab supports along with different Altair solvers are electromagnetics. If you are someone who are looking to design electric motors, all of your electric motor solution are going to be present inside one single interface, that is SimLab. Or if you're doing fluid flow or interaction between them, or if you're interested in simulating the PCBs, which are like in high demand in the industry right now. So all the simulation regarding this printed circuit boards, starting from vibrations, random vibrations, fatigue, or maybe coolings, all are supported in SimLab environment itself. And then interesting part is your manufacturing simulation. So not many tools in market combines CFD fluids and then also with the manufacturing. So yes, you can do injection molding here in SimLab itself. So let's quickly now close it and move back to the tool. And I'm going to open a new database. So the objective of second demo is to explain how easy it is to automate stuff in SimLab. Okay. So as I was mentioning in the previous demo, whatever you do on the GUI, every single mouse click is being recorded in the background in a Python script. So if I go into automation, say script and open session script, right? So everything, all the things that you do, let's say, I had applied load mapping on that model, if you remember, pressure and temperature mapping. So this complete section here is about mapping. So you can just simply copy this section and paste it in your script. So let me just quickly show you a demo how I do it. So I'm just gonna file import CAD, right? quick mesh control testing, and this is a parasolid. Just gonna import it. So if I show you a test import, so this is a test script that I just created. How I created this script is I did everything on the GUI, right? So I imported CAD. So I was importing CAD. I went into my automation scripting and session scripting. I saw what code it is writing for importing the CAD. So I saw it is okay, it is importing parasolid. I copied this completely. I said copy. Okay, you can see the path here. You can also change the path and file name if you want to convert the hard coding into soft coding. I just went into an empty script, empty SimLab script, and I just pasted on top of it, import solid. So that was my first command. I came back again to the SimLab interface. I went into meshing, surface mesh. I said I want to create a tri-mesh of 7mm size. Don't want to control any other parameters. And I just hit OK. And let SimLab do its thing in the background. What I really need is I just want that portion of code that SimLab is using to create automation. I will again go to my scripting part, open session script, copy that section of the code, and then again paste it into my empty script. So I again pasted this surface mesh script here, right? It's still hard coded because your files names are hard coded. So you are using this file. If you want to use it on some other CAD, you can just simply change the name of the geometry and you're all set to go here. Second thing that I'm going to do is after this surface mesh is state mesh. I again came to GUI. When the surface mesh was complete, I went into the tet mesh setting. Okay, I created a tet mesh. I copied it from their session script and I pasted it in my own script. And last thing was to export this mesh somewhere in the location that I want. So I wanted it to export in this location with this name. So right now, for the sake of this demo, let's change the name to model 03 so that we know that the script is actually working. Surface mesh created. As I was saying, after that, you can create tet mesh and you can also save file, export, and export this mesh here. Copy everything that you are doing from this scripting and session scripting. So you can see now SimLab has copied this surface mesh. This is what it's doing in the background, right? And just copy it in your empty file and create a script out of it, right? And when you are trying to use that script on some other part, just open a new SimLab session. And I hope all of us are smart enough to understand that if my file name is changing, I will be changing this here to change the hard coding into soft coding wherever this file name is mentioned in the script. Okay, just save the Python script, come to your SimLab empty session, go to automation, say scripting, and now instead of opening the session script, you are just going to play the script. So I'm just going to say auto and play my script. So now SimLab is reading that script. Okay, so that script contains just 3 or 4 steps. We just imported the CAD. This import CAD is completed without doing any click, just through scripting. It's now creating surface mesh since we had copied that command into our scripting. After that, it's going to create tet mesh and then export that without touching the mouse. It's just using its script that's in the background, right? So this was about a simple script. We will let it run. The automation capability is of SimLabs are huge. You can literally automate everything. Let me show you a quick example, right? So this was like a very simple script that I just showed. What if you want to control meshing parameters from some variables, or if your management has sent you some meshing parameters that you really need to follow, and you also want to keep that in an script. So you can see a script that I created. I'll just quickly go over that script. Let me see if this one is the script that I was talking about. There you go. So in this script, first I'm importing a parasolid. So you can say import parasolid. I am not that smart that I have written this code by myself. This is everything that I copied from the background itself. So you can easily do that. I am importing a parameter file that I have already created. So this is a parameter file that my management sent me that you need to keep these mesh qualities, okay, aspect ratios, that collapse and everything, okay. And then I'm reading those parameters. So you can see I'm reading those parameters, that element length or aspect ratios and TED collapse. And then I'm creating my surface mesh instead of just on one meshing criteria. I'm creating the surface mesh based on the criteria that I have given in the parameters file. So I'm just creating variables and reading the values from those variables. So this was just one level up of the automation that we created. Let's just move back here. And now you can see we have created the mesh that we were doing manually earlier. Yes, just with the use of just few commands here. Excuse me. And let's see if it has exported the mesh now. So Alfasoft, quick mesh control, testing. There you go. So it has already exported the mesh with this name. So our file had like 03 instead of 02. So this is a new mesh exported solely from those scripts. So this was all from my side regarding the demo of a simple multi-physics run and a very simple automation script about SimLab. Feel free to ask any question you have regarding the tool. Finn, you want to take it over from here?
Yeah, okay, so great, thank you. So we do have some questions here for you. The first one here is, we are already using HyperMesh. How can we use SimLab without investing extra money?
Sure. Joachim, you want to take it or you want me to answer it?
Oh, sure. Please go ahead. You can answer.
Yeah, sure. So based on the licensing type that we have, Altair licensing are based on units, right? So you can either use those units for SimLab or you can use it for HyperMesh or any other Altair tool. So you just need to purchase Altair units. Since you already have HyperMesh with you, I'm assuming you for sure having Altair units. You can simply use those units to run SimLab, but they are not going to work in parallel. You will have to close one of them and then extract those units for SimLab itself. So yes, you can use SimLab with HyperMesh without investing anything extra.
Great, thanks. So next question here is, what's the SimLab offer to the electronics industry?
For sure, yeah. So we do cater electronic industry in great details. So as I was mentioning in my PPT as well, SimLab has like excellent meshing capabilities. Maybe what I'll do is, there you go. So, and swap it, yeah. So it has excellent capabilities creating hex mesh, and you can also import files from the ECAD software, and it will automatically identify where the copper tracings and all has been placed. So, and also categorize it into submodels and assemblies to make the task easier. So these are the capabilities which are like really interesting to electronic industry right now. And we do support a solver called eFlow, which is like an Altair solver, which is used to check thermal cooling and heat dissipation and bunch of thermal stuffs for the electronic cooling. As far as OptiStruct and SimLab is concerned, you can do like random vibration fatigue or weld fatigue or solder fatigue specifically to electronic components. So these are all the capabilities that we do offer to electronic industries. Yeah.
Great. And last one we have here is, I'm new to SimLab. How can I learn it?
Sure. Yeah. So there are two things when it comes to learning SimLab. So if you have already opened SimLab with you, by installing it, on the right hand side you have a icon with, I think it looks like a book here, and you can just click it. It will take you to SimLab Learning Center, right? And on Learning Center you will find, I guess, more than 100 to 100 tutorials with videos linked and with models here. So it's like gradually increasing the difficulties for everything. So let's say if you want to do multi-physics, so there are way too many physics that SimLab support, hence you see a long list here. So if I say multi-physics and I want to say maybe the one that I just show in the webinar, so this is here on the video link. So you can actually download the model, you can follow the video, and you can learn it from the SimLab Learning Center. Another way of learning it is, or any other Altair tool, is to create your Altair One account, go to Altair's Learning and Development page, and we have the class schedule for every free class that we are going to offer in the upcoming days. So you can select the language that you wish to attend the class in, maybe English, German, French, based on your needs, and the product that you want to learn. So these are completely free classes. You just need to create an Altair One account, head to the learning and development pages, and you will see all the classes, free classes actually, that Altair is offering right now. And you can also select your region wherever you're based at. Just simply register it and you're all set to attend those classes.
Oh, that's impressive. May I ask how long these online classes are? Is it like an hour or?
Yeah, so it really depends the tool that you are going to use. So let's say I am hoping SimSolid is a small tool. So I'm just going to click in and see. Okay, so this is not actually small. So this is 3 hours, but it's just one day. So 3 hours a week, so just one session. Usually the tools are very extensive. Let's say OptiStruct. So OptiStruct classes are usually 3 hours per day for 4 days a week. So it really depends on the tools that you're aiming to learn.
Yeah, that's impressive. Interesting. So, and with that, I don't think we have any more questions. And so thanks a lot, Himanshu, for a great presentation, and you too, Joachim, for being with us.
Thank you for having us.
Yeah.
Thank you, guys. Yeah.
Impressive tool. To be honest, it seems like Altair are expanding their portfolio with new software on a fairly regular basis. So you sure have a lot of different tools now.
For
For
sure,
sure, yeah.
for sure.
Yeah. So with that, maybe I should take back the screen. And if anyone has any questions regarding any of today's sessions, please send an email to info@alfasoft.com, and we'll make sure to contact the different vendors and ask them any questions that you might have, and we will include those answers in the email that we will send out hopefully by mid next week. So with that, thanks to Joachim and Himanshu. Hope you have a great evening. And to the rest of you, thanks for joining, and see you on the next online demo day.
Thank you, guys. See you.
Thanks. Bye.